Okay, today's lesson is 1-2b, so the second part of analyzing graphs of functions and relations. We are going to explore symmetries of graphs and identify even and odd functions. So, from geometry, you talked about it in Algebra 2. We have two types of symmetry that we're going to talk about with our graphs, line symmetry and point symmetry. So these first two, if you remember, line symmetry means that I fold it on along a line, then it'll match exactly on both sides. So this first graph is symmetric to the x-axis because when I fold it on the x-axis, then this part will fold on top of that one. This one has line symmetry with respect to the y-axis. If I fold it along the y-axis, they will match. Okay, and then this one has point symmetry because if I rotated it, then 180 degrees, it would look the same. So when I have any point x, y, I also have the point negative x, negative y. Okay, so the key things about this, as you're reflecting over the x-axis, notice when they have this point, the only variable that changed is the y. So when we have to prove things algebraically, we're going to see if I have both of those points on the line, if it's symmetric to the x-axis. So symmetric to the x-axis means the y and negative y are on my graph. Respective to the y-axis means x and negative x are on the graph. And symmetric to the origin means I'm going to have negative x and negative y. So first and foremost, I want y'all to know how easy this is to get these answers by looking at your picture. So each of these answers you should know before you even do the algebra. We're going to confirm it algebraically. Okay, so when you look at this graph, okay, if I folded it on the y-axis, then it would be symmetric. So I should know that it's going to be symmetric to the y-axis. It's not symmetric to the x-axis, and it is not symmetric to the origin. But let's go talk about what you have to do algebraically when you have to prove that. Okay, if it's respect to the x-axis, then the y, I'm going to have a positive y and a negative y. And it all has to do with this equation right here. So if I have y equals negative x squared, this equation right here is coming from any point x, y. Well, what if I plug in x negative y? Well, if I plug in x negative y, then instead of positive y, I'm putting in a negative y. And if I simplify that by multiplying both sides by -1, I get y equals x squared minus 6. Well, that's not the same thing. Those are clearly not the same, so that's why I know it's a no and not symmetric to the x-axis. Okay, if it has y-axis symmetry, then I'm going to have an x and a negative x. So I'm going to go plug negative x into this equation and see if I get the same thing when I simplify it. So the first step, plug in negative x, and negative x squared is x squared. So when you simplify it, it becomes that. And that equation is the same as my original equation. Okay, and last but not least, we have the origin. All right, so I have x, y, and this time I'm going to take it and I'm going to plug in negative x and negative y. So the negative y stays the same, but my negative x becomes negative x squared. And if I multiply everything by -1 to solve for y, so because I want to see if this is the same as that, you can see that it's not the same. So we had the answer of no. Okay? All right, look at this next one. We have x squared plus y squared equals 25. So let's do it graphically first. When I look at that graph, can I fold it on the x-axis? And would it be the same when I fold it? Would those two pieces match? And surely y'all know that answer is going to be yes. If I fold it on the y-axis, is this side going to match that side? And again, you're going to say yes. Now, with respect to the origin, if you find a point, and let's say I go here, which looks like it's 4, let's just say it's 4, 3, then I would go to -4, -3, and it looks like I have the same thing. So I'm going to say yes. We're going to confirm it algebraically. So again, if it's symmetric to the x-axis, then I have to have a positive and a negative y. So I'm again looking at this equation here, which I obviously forgot to write. So I'm looking at this one, okay? And I'm going to fill in and plug in negative y. So when I plug in negative y, well, negative y, that's why I mentioned to y'all earlier, it's always so important to put parentheses when you plug in a negative value, negative number or negative variable, because whenever you square it, because of those parentheses, it's going to be positive. So that equation there, x squared plus y squared equals 25, looks just like that one. Okay? Symmetric to the y-axis means I'm going to have an x and a negative x in there. So this time I'm going to plug in negative x for positive x. And again, have my parentheses around it. So when I square it, anything squared is positive. And again, I end up with the same equation. This matches my original equation. And then we go to the origin, which means I got to have a negative x and a negative y. So this time I'm plugging in negative x and negative y. Again, with my parentheses, anything squared is positive, so it's going to simplify to this same thing of x squared plus y squared equals 25. Okay, real quick, so make sure you don't have any trouble with your homework, I wanted to review the degree of each of these equations. Okay, so the degree of any equation, y'all, is equal to, I don't know. Oh, I didn't want to. That's what. Degree of any equation is the degree of its highest term. Okay, the degree of a polynomial is the degree of its highest term, and the degree of any term is basically the highest exponent. So the degree of this equation here, y equals x squared minus 6, or negative x squared plus 6, the degree of it is 2. So what is the degree of this equation? Again, the degree is 2. So just keep that in mind when you're going through and doing your homework problems. Okay, last thing we got to talk about, even and odd. So these two types of symmetry, when you have y-axis symmetry and symmetry with respect to the origin, they have special names. Okay, one of them respect to the y-axis. If your function is symmetric to the y-axis, then it is referred to as an even function, and if it is symmetric to the origin, it is called an odd function. So we're given three equations, and we're going to go graph the function, because we just talked about it. It's so much easier to determine the symmetry by looking at the graph. Look at the graph, determine whether it's even, odd, or neither, and then confirm it algebraically. And so the algebraic confirmation is a little bit different, but we're going to talk about that. So we're going to do some examples so you'll see it. Okay, so to speed this up, we already talked about graphing, so if you need some help with class calc or another graphing utility, let me know. But I went ahead and put the graph in here to speed it up. So that is the graph of f of x equals 2 over x squared. So is it symmetric to, I only need to know, y'all, if it's symmetric to the y-axis or the origin. So is this symmetric to the y-axis? If I fold it, is it going to match on both sides? Yes, it is symmetric to the y-axis. So it's an even function. And if it's an even function, then I have to come up here and prove that f of negative x equals f of x. Okay, so to do that, I like to write down, is f of negative x equal to f of x. So f of x is 2 over x squared. But f of negative x means I'm going to go plug in negative x for x squared. Negative x for my x value. And when I simplify that, again, it's in parentheses. So when I simplify it, I get the same thing. 2 over x squared equals 2 over x squared. So I have proven algebraically that my function is even. Okay, look at 6b. G of x equals 4 times the square root of x. So I graph it. Okay, is it symmetric to the y-axis? Can I fold it and have the same thing on both sides? No. Is it symmetric to the origin? If I have a point on here, this point looks like 5, 9 right here. If I have 5, 9, do I have the point negative 5, negative 9? I don't. So in that aspect, I'm going to say that this one is neither. And if it's neither, then I have to start off proving it's not even. So I'm going to go look at, does g of negative x equal g of x? And so when I go plug those in, I put negative x. Y'all, I can't take the square root of a negative number. So since I can't take the square root of a negative number, there's no way possible for these two functions to be the same. So they're not even. Now, for it to be odd, I have to prove it like that up here. F of negative x equals negative f of x. Okay, so what is negative g of x? That's supposed to have a negative inside of there. Okay, this is supposed to have a negative right there. Wait. Okay, so what is negative g of x? Well, that looks like this, and this again would have my negative inside, because that's what we just figured out. Go away. Okay, that's what I just figured out right here, okay, is that this g of negative x is right here. So that's what I have right here. And negative g of x is this. And those are not the same thing. We already talked about that. That doesn't exist. Okay, so last one. G h of x equals x to the fifth minus 2x cubed plus x. So here's my graph. Okay, and when I look at that, that kind of looks like it might work. I have this point right here that is, let's just act like that's 1, 1. This one right here. And if that's 1, 1, then this over here is negative 1, negative 1. So I'm going to guess that that's odd function. Okay, so that means I have to prove, does h of negative x equal negative h of x? So with an even function, y'all, the negative kind of goes away. And with an odd function, the negative goes outside. So watch how you do this. I'm going to go plug in negative x for everywhere that I had a variable. And on this side, on the right side, I put the negative outside of my function, because this is my original function up here. So I'm taking the original function. Everywhere I have x, I put a negative x. Over here, I put the negative on the outside. And now I'm going to go simplify both sides. So a negative x to the fifth power is negative. Negative x to the third power is negative. So that's going to switch and be positive 2x cubed. And then plus a minus. So this simplifies to here. And when I take that negative and distribute it through, then it becomes that. And you can now see that both sides are the same. And so we have h of negative x equaling negative h of x. So those are your odd and even functions. Hope that helped. If you have any questions, please don't hesitate to email me or your teacher, or come by and see me or your teacher. Y'all have a great day. Thank you so much.